Hello and welcome to SciJoy. Previously we learned how to track the motion of the sun. In this video we're going to program and wire the sundial. You're going to learn about analog sensors, arrays, for loops, if statements, and how to calibrate a circuit. We can use light-dependent resistors, also known as LDRs, to monitor the sun and the shade of the sundial. This is what the finished sundial will look like. We're only using 6 sensors because the Arduino only has 6 analog ports. The resistance goes down in the sunlight and it goes up in the shade. To measure the voltage drop across the LDR caused by the change in resistance, we need to use a voltage divider. One end of the LDR goes to the power and the other end is going to go to the analog port. And then we're going to have a resistor going from the same analog port down to ground. What value should we use for this fixed resistor? We need one that is calibrated for our project. The Uno uses a 10-bit analog to digital converter, which means theoretically this gives us a range from 0 for an absolute dark object to 1023 for the brightest object. The sundial will only be in sun and shade, which means neither of these extremes are going to be used. So we need a resistor that is sensitive to our voltage drop range in the sunlight and in the shadow. So we tried a 1 ohm, a 10 ohm, a 100 ohm, a 1 kilo ohm, a 10 kilo ohm, a 100 kilo ohm, and a 1 mega ohm resistor to see which one would work best. We put the LDRs in the sun and the shade for each of these resistors and recorded the values using the calibration code in the description below. This chart shows that the average range from lowest value to the highest value was about 200 for both the 100 ohm and the 1 kilo ohm resistor. This means that those resistors, or anything in between, should work best for our project. Instead of switching out all those resistors, you could use a potentiometer, which is just a variable resistor. We don't need this to be a permanent project, so we used alligator clips, breadboards, and jumper wires instead of using solder and PCBs. We picked the hours that we wanted to monitor and poked holes through the template for the LDRs to fit through. Using a compass on our phone, we pointed the sundial towards north. The Arduino will plug into the computer to receive power and code, and it will also transmit data over serial port. Let's start writing our code. This is what we use for calibrating the sensor. Pretty much the entire code is about reading from the analog port, then printing those values out down here. So it's going to read it, store it, and print it. So we wanted to define the pins that we're going to use. Those are constant values. So we're going to use constant integer at the very top because they're going to be global variables, and we said that LDR 0 through 5, and we defined them at analog ports 0 through 5. Then we knew we were going to store them somewhere. These are changing numbers. They're going to be, whether it's in the sun or the shade, it's going to be those numbers from 0 to 1023. So we defined them up here, also global variables. They're integers, and we're going to start them out as 0, and they're going to change as we read from the sensor. And we have brightness 0 through 5. We're going to set things up one time. So we're going to say turn on the serial ports. That serial begin. This way we can see the values come to the computer. And we're going to use 9600 as our baud rate like we did before. And then I wanted to put a header on our output text. So I did serial print sensors 0 through 5. So this is only going to appear once, which is why we did it in the setup portion. And then when we get down to the void loop, this is the part that's going to go over and over again. All we did was read each of the analog pins and then print it to one of our brightness variables. So down here we print out each of the brightnesses, and I also added a serial print with a comma and a space. This way not only does it look nicer, but if you're going to put it in Excel or a Google spreadsheet, you have a comma separated value, and then the last one has that print ln, which means it's going to do a hard return. So I have a short delay here because we were calibrating it, but for the actual use you're going to want it to be longer. This is only a second, so you might want it every few minutes because you don't need to know what the sundial is saying every single second. So for this program, we're going to use arrays, for loops, and if statements. We're going to start off with using our brightness array. Instead of defining each of these brightness terms, we're going to create an array for it. They're all integer terms, so we're going to start off with int, and then we're going to say our array is called brightness, and then we're going to use 2 square brackets are equal to all the initial states that we had over here in one line. And they're going to be inside these curly brackets. So the difference between an array and what we have over here, where we just call out every single variable, you can kind of think about it if you're a waiter or a waitress at a restaurant. This is kind of looking at, okay, table 0 wants what? Fish. Table 1 wants chicken. Table 2 wants beef. Table 3 wants fish. Table 4 wants beef. Table 5 wants chicken. And you're going back and forth between the tables in the kitchen every time. Now, if you were to use an array, it's more like having a tray that you can just carry all these dishes out at once to tables 0 through 5. Then we're going to move on to the void setup loop. We're going to use serial.begin to open our communication with a computer. That's going to be 9600 baud rate. We're going to use serial print line as our header again. And we're going to put our values for our time in there instead of our sensor numbers because we've chosen certain times for certain sensors. So we chose 7 a.m., 9 a.m., 11 a.m., 1 p.m., 3 p.m., and 5 p.m. Then inside of our main void loop, we're going to again read all the values off of the analog sensor, but we're going to use a for loop to do this. And it's kind of like when we were doing the robotics and we said, do this thing until this condition is met. So this is saying, do this loop for as long as these conditions that we define at the top are met. The header for this for loop says we have a local variable, which is I, and that's going to be an integer that we set to 0. Global variables are put at the top. That's where we put our brightness. And we're saying that as long as I is less than 6, you're going to keep doing this for loop. And this special operator at the end with the 2 plus signs with I means that every time you go through this loop, you're going to add a number. So I is going to start at 0, and it's going to go through the loop and be 1, then 2, then 3, then 4, then 5. And then we're going to exit out of that loop and go on to the next part of the code. And for us, we want to say that brightness I is equal to analog read I. This is saying that brightness 0 to start with, so 0 is your index number, so that's your first placeholder in your array, is going to be equal to the analog read that you have on position 0 of the Arduino. Then we go through the loop again, and it's going to be brightness at index 1 is equal to the number you read off of analog port 1, and so on. And then we want another loop because we want to do some logic this time. We want to know if we're in the sun or if we're in the shade, not just have numbers, because we did a calibration test and we can use those numbers to put some logic into our code. So we're going to make another loop. And this for loop, we'll use j as our local variable, and it's also an integer. And we're going to say as long as this is less than 6, you're going to keep doing this and add a number to the loop every time. We're going to use an if-else statement. And this is kind of like the switches that we used in robotics, where you make a choice. If this condition is met, you do this one thing, and if it's not, you go do this other thing. So what we're saying is if the brightness at position 0 is less than 270, then we want you to go down and we want you to switch out whatever number that is that's less than 270 with a number 1. If it's not, then we want you to switch out that number to a 0. So what this is pretty much saying is go through each place in our array and either have a 1 or a 0. So if it's in the shade, you have a 1. If it's in the sun, you're going to have a 0. And we need to print out our values like we did before, and we're going to use one last loop for that. Again, we're going to have an integer that's set to 0. We're going to go through this loop 6 times, and we're going to print out the value for brightness every single time. We're going to add a comma to it, and then we're going to exit out that loop, and we're going to have a return. So we go down to the next line, and we're adding a longer delay to it this time. So that's how we can use arrays, for loops, and if statements. Thanks for watching this episode of SciJoy. If you have any questions or comments, you can leave them down below. You can talk to us on any of these social media platforms. You can support us at patreon.com/SciJoy. And remember, keep exploring.